Yes, thanks. So thank you. Welcome everyone. I will be co-presenting at one stage for a few slides with Mark Dixon, my colleagues, which I believe at one stage will be possible to have him vocally, I would say, hearable. So the whole idea of this presentation today is to give you a little bit of I would say an insight about where we are today in terms of our development, and more interestingly, potentially, is where we think we could go, and opening the discussion during this presentation, but of course afterwards with the community to receive feedback about what would be wise to do and not wise to do. So that's a bit of the idea about what I wanted to present today. Do you see my screen well? No problem?
Yes, no problems.
Okay, perfect. Sorry. Okay, so in fact, I just wanted to start briefly by telling you, in a way, why we could consider that we are quite qualified in a way to try to address this approach, and why it's important for us. First, of course, we are an APN member for a long time, and we have been watching what was happening with Allotrope for a very long time, expecting something to happen, and being part when it was possible, and when it was, we thought we have something to contribute to. The nature of Mestrelab is to be vendor agnostic, so reading every format in NMR, but not only in NMR. For us, our job starts when we can visualize data and do something with the data. So opening data is critical. And we have been involved in NMR for almost 2 decades. So working hard in providing capabilities to use the data. So as I said, having access to the data is very important. We have a long relationship with a lot of the founders of the Allotrope Foundation and the member of the Allotrope Foundation. So we have heard a lot, we have exchanged a lot about this. And we have also a strong relationship with Bruker, as you maybe know, for some time, but also with a lot of other instrument vendors, not only in NMR, but strongly in NMR. So for a lot of different reasons, going in the direction of trying to do something with NMR is the first logical approach we have decided to address. Additionally, I would say, so this relationship with Bruker was giving us some capability to do things more, but in the same time, we were lucky enough to have Mark Dixon with us, and Mark has been a product manager for VNMRG. So we had now the possibility to have 2 different instrument format more deeper in our hands. Sorry, where's my... Okay, so as you maybe know, based on the initial approach addressed by Paul James Jones and Justin Van Wien at Pfizer and BI for Paul James Jones, we have approached the converter by following their suggestion, which was to put the raw data, the FID, the process data into data cube, the proprietary format in the data package. But more importantly, of course, a more critical approach was to consider what we can do with metadata. We have approached this using the formerly leaf node approach, which is a tabular data model now, placing all this into the data description. This was announced 6 months ago, and now it has a late beta stage. The way we are going to commercialize this is through an automation product called mGears, which is a very easy interface to decide what is the input, what is the output, and what you want to address, what you want to do. I'm going to show you a little bit of this in a minute. So this will allow to automatically track and take any new data acquired somewhere and place somewhere in a folder, and convert into ADF and place this ADF where you want this to be placed. Okay, so I'm not going to explain the leaf node or the tabular data model. Again, you probably have heard a lot about this, but some maybe in the audience may not be too familiar. But in a way, I think I've decided to use this slide, which is a very easy summary for everyone who will be more new in this field. Metadata can be acquisition time and value, and the leaf node approach, a tabular data model approach, is to define these to explore this in a way in different pieces with more definition. So as numerical value, as unit, as label, as symbol, as definition. So this creates a lot of information which can be compiled into the triple approach and provide this more precisely in a way and derive all this information in such a way that it can be reusable later on and build more ontology and so on. So we started with this and we developed the converter for the Bruker instrument format. So based on that, we have now a Bruker to ADF module, which can be addressed using our tool called MGear, which is kind of a brick-based approach to create easily, I would say, automation. So you can read, you can address this using real-time acquisition. So when you have something acquired, you just have to define which folder can be watched. And every time there is new data, it will be automatically converted transparently. You can also run through this like batch operation. So if you want to take thousands, millions of data into some hard disk and convert everything into ADF to place it somewhere, you just have to define where, I would say, if it's real-time or batch automation, and where you are going to take the information and where you want to put this information in the output. So that will be quite simple. And you also have to define, I would say, just say, okay, in that case, brick, which is just a different analytical tool we can provide for automation. Like in that case, Bruker to ADF, B to ADF bricks can be add online, but the same tool can be used for more capabilities. As you can see here. So in that case, the Bruker to ADF is going to convert. In the future, we will have the Varian to ADF as well. And when it has been used, you have now your ADF somewhere in the output where you have defined in the folder, where you have defined in MGears. And if you open and start your ADF Explorer, you will see your ADF file, and of course more than that, but that's just an example. And I click on this ADF format, and I see immediately that I have my data description, my data cube, my data package. Data package, of course, include the native instrument format. And in that case, there was also a molecule, which referred to our Mnova tools, but it's just an alias. It can be opened as a mol file, it can be opened with any software reading mol files. The data cubes include all the process data and raw data as well. And the data description will include all the information about the metadata. So if I click on the data description, I will see this on the screen with the subject, the predicate, the object, and I will have all this information, which is, of course, searchable, and all the definition of the metadata will be according to the Allotrope recommendation about the tabular data model. Same now view of the data, 1D FID, 1D process data, or 2D. That's classical, but that's not the most complex. The most complex in that case was to be able to create the data model in the data description, so to place all this into the data description. And this is what we did with the help of Paul and Justine. So maybe at this stage, I want just to give you a bit of ideas about the difference between what we have done for Bruker, what we are doing for Varian. So Bruker is done, Varian is in progress. I'm going to ask Mark, who was involved on this, to tell us more about the differences between the two instrument format, which explain a bit of the complexity we have been facing when we were building those two converters. Mark, do you hear me?
Yeah, can you hear me now?
Perfect.
Okay, thank you, Guy. And good morning, everybody, and good afternoon as well. So I'd like to talk on behalf of the technical team at Mestrelab. We have a very skilled set of developers, and once again, they've excelled themselves for this project. And I want to briefly talk about some of the challenges to create these converters. So, yep, you've got the right slide. So in Bruker NMR world, metadata structure is defined and predictable. While things changed from version to version over the years, all of those changes were documented and all the users got the same experience. The picture on this slide is a small portion of the parameter space to set up data acquisition. Excuse me. Every user gets the same interface, and the same set of parameters that it can work with, no matter if it's a simple proton spectrum or the most complex pulse sequence in the toolbox. It's just the parameter values that change. So when user-configured parametric values need to be preserved with the dataset, then the user has two choices. They can capture the metadata in a free text file, which Bruker called the title file, or they can hijack one of the existing parameters that is idle for the experiment of choice. And so when considering an ADF converter, this is a relatively simple one-to-one mapping exercise for Mestrelab. And Paul James Jones at BI did the heavy lifting here along with Justine at Pfizer and passed on a lookup table that allowed us to implement a converter very quickly. So next slide, please, Keith. So when it comes to Varian NMR world, the philosophy is very different. While Varian supplied standard parameters, which evolved over time with subsequent releases, just like Bruker, it's worth noting that there is no universal parameter space. Each type of NMR pulse sequence has an associated parameter set that is different to all the others, even with within the same software release. So on the slide here, you can see a picture of two VNMRJ parameter panels. The top one is the simple proton experiment, and we're looking at the acquisition parameter set. And the bottom one is a more complex 2D proton-carbon correlation spectrum. And comparing these two data sets or parameter sets, there are many parameters that are present in one that are not present in the other. Added to this, Varian allows the creation or deletion of parameters. In fact, this was recommended behavior from Varian, who promoted users to make their own unique parameter sets. So while custom metadata can also be captured in a free text file, it is far more likely that unique parameter sets may be present with their own parameter types and values. Now, in my experience, those created parameters and their values tend to be highly pertinent to things like project ID, molecule ID, user ID, etc. So it's always important to keep an eye on the prize here and think about how these files, ADF files, will be utilized down the line. And so once analytical data is contained in a data lake and becomes an information source that can be easily mined, it's highly likely that search filters will include project names or numbers, molecule structures or substructures. So in other words, metadata that the scientist will have added to the pile rather than values associated with the inner workings of the spectrometer. So next slide, please. So when it comes to implementing a Varian ADF converter, at first it may seem like an impossible problem to solve if the input data is unpredictable and potentially unique. So how can we put together a converter that still gathers all of the parameters, whether vendor defined or homegrown? Now, the way that we plan to do this is to gather all of the standard vendor supplied parameters, their types and units, across all of the released versions, and use this as a preliminary lookup table similar in nature to the Bruker model. And the answer really is quite simple, in as much that anything left over is then defined as user parameters and will be captured separately and supplied to the data description section of the ADF so that searchers can easily find the information quickly and easily. This work is underway and we hope to present a beta version to the Allotrope community in the near future. And just in closing my section here, Mestrelab is vendor agnostic, as Guy said. So in theory, the Bruker and Varian formats that we've worked on are just the tip of the iceberg. We're open to work with all of the other vendors and all they need to do is contact us. Over back to you, Guy.
Thank you. So in a way, I would say if you come back to the leaf node, Bruker is done. Of course, there is probably something to adjust and you may find aspect which can be improved in the future, but it's done. The Varian is in progress. What it means in a way, which interesting aspect is what are the next steps? And that's what I want to speak in this second section of the presentation. So there is different next step which can be, of course, considered. What about establishing a consensus approach for the main metadata parameter from the different instruments, importing this into Mnova, adding assignment, multiplet, adding structure, adding some other properties to the ADF, mining into data lakes or in type of environment and ecosystem. So let's start with the first one, which is asking also you questions, which is what about a consensus approach. So if you consider this as the data description section of an ADF file, what we have done so far with Bruker, considering one parameter, which is spectrometer frequency. So we have now described all this into the data description approach and following the tabular data model approach. And soon, assuming we are now considering an experiment which has been done with two different instruments, a Varian instrument and a Bruker instrument for the same experiment. So the information will be stored into the same ADF. You will have now two ways of describing the spectrometer frequency with this own information in a way and their own definition. The other approach could be as well that, of course, you will have an experiment with an ADF with a Bruker information and the spectrometer frequency, of course, another experiment starting with Varian. That will be in two different ADF. Program will still be the same. How would you search, for example? How do you compare all this? So if we go back to the first approach where the ADF contains two different type of data, Bruker and Varian, one of the questions could be, do we want and would it be a good idea to create a consensus name in a way for this spectrometer frequency, which can be contained into the ADF, which will allow more easy retrieval of the information, more easy mining of the information. So that will be an approach, and we could potentially ask the community to give us guidance about what can be done. In a way, we are ready to do it in a sense. We simply need to have a recommendation about what are the most important field you want to capture. That would be an approach, and what type of approach you want to follow. And of course, the other idea will be that other format can be added. In that case, of course, an experiment with three different instruments, three different formats, but why not? That will be exactly the same. But you can also consider differently as well the approach where you have a Bruker data in one ADF and a Varian data into one other ADF. So how are you going to potentially more easily retrieve your information? There is always tools for doing this, but from an allotrope organization approach, what would be the best way when you have now two different experiments, two different definitions for the same type of parameters? How do you want this to be more reconciled? That would be a question asked to you. We have our ideas. We'll be ready to discuss and work with you in such a way that we can go to the next step. It could be, of course, that somewhere we store a table in a way or a way to identify a consensus, a link of the different consensus nodes, for example. Different ways can be done. At the end, also in a data lake, you can have always mining tools can search in the same time two fields. So if you know the definition of those two fields, it's easy, but nobody in a few years will necessarily know the differences. That will be potentially more difficult. So this is an open question. What's going to be delivered soon in a way is Bruker and Varian in the same time, which is a very interesting step. But this step being done, it opens even more capability, more possibilities. Next approach, of course, which will be logical, of course, is importing an ADF into a classical processing software, in that case, Mnova NMR for us. It's a natural evolution, of course, but there was no need for rushing in a way, because now we have beta testers, we have some adopters, hopefully soon. So when it will be adopted, it will be interesting for customers to be able to open an ADF, not only in ADF Explorer, but being able to open an ADF in our environment, for example, will be, of course, interesting. So that's the next step for us. Most important is to provide to the community Bruker to ADF and Varian to ADF, which in a way, I would say, when we think about the reason for doing all this, there is two very important reasons. One is, first, in a way, is being able to convert any new acquired data and place this data into a data lake, for example. Okay, so that will be with existing instrument and existing format will be important. But the other approach will be also to take all the legacy data and convert this and place all this legacy data into one unified format into a data lake, for example. And in that case, Varian will be important because it's a very important legacy. So for us, doing Bruker and Varian first was making perfect sense, because also we had the chance to have the expertise. And that will be a very interesting example for the community, and we are expecting you will be giving us feedback. But reading in Mnova is, of course, the next step, which will happen sometime this year, in fall probably. The other next step, which could be interesting, is to add assignment, multiplet structures. this will be a talk on its own, and there will be people even more expert than me. I'll be exchanging information and discussion with Paul and Jones, for example, and I think he has passion about this, and I think it would be very interesting to have this discussion, but that will be too long to discuss. But in a way, we have done now FID and process data, we have done the metadata. So assignment and structure will be the natural next steps. How is it going to be done? And when you see the level of complexity, there is ideas, we know a little bit where to go, but we need also to get confirmation that what we are going to develop is going in the right direction. So we'll be looking to your feedback as well. I wanted to add this because you may have seen that there was something called SQA in the automation, which is a spectrum suitability test. And I just thought that maybe having in mind the context I just mentioned about where we want to go, it may be interesting to potentially add some additional properties. So a lot of things can be done, but why not, when you take all your legacy data, adding a testing system, which is going to analyze the quality of the data in a way, in such a way that when you retrieve all data, you already have a test. So yes, tools exist. We have tools we can do all that, analyze, I would say, the acquisition parameter, processing parameter, phase, signal to noise, and so on, and provide you I would say, an SQA testing report. Is it a value to put this SQA report into an ADF, and where to place it, and where to better place it for an easy finding? This is something interesting to discuss, and I think there will be probably some other properties you may have in mind, which we may do or not do, but it is important in my view to think about what the value of what you create when you create an ADF, and to be able to retrieve very interesting information for the future. So this is a tool which is coming with our Bruker to ADF converter, as well as our Varian to ADF converter when it will be ready, which analyze the quality of the data, but there will be some other possibility as well. And the last one, because I always try to keep in mind what we want to do with this in a way, the last one for me very interesting is mining in a way. So because now you have a lot of information, you create this information, place this information somewhere. What is very interesting is how do I retrieve this and what can be done? So I just wanted to show you an idea, and there will be probably plenty of others in a way, but just projecting yourself in, okay, we have now a converter for NMR for Bruker, we have a converter for Varian coming, we may have some other coming as well, of course, because as Mark said, we are open for this, and it's logical, of course. So now it's every time an instrument is acquiring something, a Bruker instrument, or still an old Agilent instrument already there, is acquiring data. The data can be captured right away, convert to ADF. The ADF can be moved to a data lake, for example, or to any type of container for saving information and archiving information. Same idea as well, we can take, because the same tool can be used to search into all your RDs, all your archiving environment, retrieve all the legacy data, convert this legacy data into an ADF again. Now this ADF is adding, is on the data lake sitting here. You may have millions of information, which of course the interest will even start now. Of course, we may have built a consensus node, so that will help you finding more easily the metadata. That's one of the goals, of course, of the ADF format. That would be, of course, very interesting, but also making spectrum searching, subspectrum searching, structure searching, if we find the best way to put structure on it. So finding all this information will be very useful. Now, one of the tools we could provide will be an indexing capability. At the time where you convert your data and place your data into your data lake, we analyze the information and extract some information which will make the searching easier. So that will be one of the ideas, and MnovaDB can be used as a kind of indexing in a way to more easily help the retrieval. So that will be one of the ideas in a way, placing your information to a data lake, make it this information live in a way. And why you want to do that? Because at one stage you want to connect those mining capabilities which we could provide to your decision-making dashboard, or which could be just verification, for example. You want to see if you have done this before and just searching your spectrum to retrieve the spectrum into a database. Or, and that could be also something we could provide, is creating, preparing, I would say, all the data we can capture at the time of the transfer. When we index it, we can prepare the AI descriptor in such a way that after that you can apply some AI capabilities your AI capabilities, our AI capability, when we will provide some, doesn't matter in a way, but at the time of transferring your legacy data into an ADF, some capabilities can be applied, something can be done in such a way that in the future you will take even more value. So I just wanted to open this at the end of my presentation in such a way that you can project a bit yourself a little bit further in a way, considering what can be done with all of this. So in conclusion, in such a way that we can have a few minutes for question, if there is any, of course. We already have a converter for Bruker, and this is aligned with the Tabular Data Model. We have adjusted recently with a few modifications which was made, so this is up to date. It's a good first step. With Varian coming in development, we will offer, in my view, a very important step where two formats of the same technique are either in the same ADF or in two separate ADF, but it's the same technique, and we know that we can take a lot of value out of NMR, so that will be interesting. This will open a lot of possibilities. Still, as I was mentioning, numerous questions for the community. That will also allow searching, mining, and so on. So think always about, let's do it, but test value right away with what we do. And that's very important in my mind. We are committed to work on this. We are committed to develop more. Allotrope I have a lot of passion for this. I've been immersed in different companies and working with Allotrope all the time. So we are committed to do this, and I think it's very important. We are committed also to listen to the community in such a way that what we provide is really adjust to what you want to do. So please go back to us at any time and discuss with us in such a way that we can really evolve in the right direction. And when you want, please ask for a test of this first converter. It is ready to go. Thank you very much.
Great, thank you, Guy. We have some time for a few questions. Jamie, do we have any that are queued up?
Nope, no questions queued up and no hands raised.
Okay.
Maybe I'll ask one. So I think this is really great work that's been done here, and I noticed, right, you spoke about sort of unifying Bruker and Varian. And I was wondering if you guys have taken advantage of any of the working groups, right, that we have within Allotrope, right? I know that we do have a NMR working group. I'm not sure if it's in active use right now, but we could obviously start that up again. And the questions about sort of the terms and things like that, I'm wondering if there's an opportunity for our modeling working group to help out there to reach the consensus that you were talking about.
I think you answered the question in the time where you were asking the question. You're absolutely right. I think we have not been recently involved in the NMR working group, but I think what I wanted to do also with this talk is give you an idea about where we are, but in the same time also open questions, because the worst thing we want to do is to develop something, and when it's finished and we have done hard work, you say, yeah, but that was not really what we wanted. So the community will have to give us guidance, but I think sometimes it's easier to receive guidance when you show something. So when you have two formats, you immediately start to create, okay, what's next? When you only have one format or nothing, it's hard, it's still virtual. Now there will be very soon two formats. So a lot of questions which maybe have not already raised the thinking will suddenly appear and say, oh, by the way, why not about this? What if we were doing this? So I hope this will come, but it may come on an individual basis. Hopefully it may also come from a community asking questions. I'm absolutely interested by this approach.
Great. Yeah, you found me out, right?
Yeah, we do have one hand raised. Paul, I'll unmute you here. There we go.
Great, thank you. Just to provide some additional clarity. So before the NMR working group went on hiatus, I wouldn't say it was disbanded. It sort of went on hiatus for a period of time. Before they went on hiatus, there was actually a consensus set of terms that was determined from Bruker, Mestrelab, and ACD, and so we would welcome community input into that, and we now I think is a beautiful opportunity for us to be able to carry that consensus list forward and then ultimately get that in an Allotrope data model. An important point though, that consensus list is use case driven, and so it's really driven by values that are required for existing software packages in the marketplace. And so as such, it is actually a very small percentage of the whole metadata collection. So we're probably looking at, about 50 to 80 odd terms, something like that. We could certainly augment that if there are specific use cases that would require us to do that, but we already have a head start on determining, where to begin to focus in terms of defining consensus terms.
Yeah,
That sounds great.
And we can always start small in a way. There is no need to wait until we have 80 terms. We can potentially start with a few terms, and software will evolve anyway. It will be maintained. We'll be continuously maintaining it. So if there is a top 10, 15, 20 we want to start with, that would be the ideal scenario to start.
And I would agree with that. I mean, there are some very, very specific values, a very small number of specific values that are required to interpret almost any NMR spectrum. And so I would propose to focus on those values first. And then once we get those under our belt, we can potentially expand from there.
That sounds great. Thank you both.